Welcome, my friends. In this video, we're not going to be reviewing one, not two, but three PCs. The funny thing is, this one has an RTX 3080 inside, that's 3070, and that's 3060. Let's have a look. So then, what is this PC? These are mini PCs, but on another level PCs, because they're from Zotac. Remember we did the Magnus one a little while ago? Well, this one is a little bit of a newer version now, and it's got some killer GPUs inside. This is the EN173070C. Ultra 4K, GeForce RTX, Thunderbolt 4, dual LAN. What's not to like? So it comes with some literature, but as well as a Windows, actually like an install stick. So if you need to install Windows, this is a read-only drive. That's a nice thing that it comes with. Quick start guide and so on. Then we have the power brick. Look at the size of this. 329 watts. The UK plug and some Wi-Fi antennas. And then now underneath we have the actual PC. Look at that. Now, as you can see on the back of the PC, no matter which inside you get, whether i5, i7 or RTX 3060, 3070, 3080, you're still gonna get the same ports and kind of the same I/O. So as you can see here, we have two LAN ports. One of them is gigabit port and one of them is 2.5 gigabit port. We have a lot of display outputs. So two display ports and then two HDMI ports. Then we have four USB ports in the back. They are 3.1, so 5 gigabits in speed. And then we have the Wi-Fi and Bluetooth antenna. So it's Bluetooth 5.2 and Wi-Fi 6. On the side, we can see this is where the intake or outtake comes of the cooling. And then we have Kensington lock as well. So this is on the left side. And then now the front. Well, there's a peel underneath a peel.
A donut hole in a donut's hole.
In the front, we have the power button. Then we have another USB type A port, which is 5 gigabits in speed. Then we have a Thunderbolt 4 port in the front here, which is very nice to see. And then we have an SD card slot, microphone and headphone jack in the front. So in terms of the inside of the PC, I suppose we're just gonna undo these screws in the back there. They're not really thumb screws. Okay. And then you push it that way, and then voila, that's an NVMe fan over here. As you can see, you have your Wi-Fi card here, which you can upgrade. Then we have a full 2.5-inch SATA port here for your hard drive or SSD. As you can see, we have one hard drive installed in here. By the way, they come as bare bones versions, but I think this one is sample unit with some of the things installed, so you can just see basically. Then you have one NVMe slot and then a second NVMe slot, which is very nice to see. And then two RAM slots, and these are DDR4 RAM slots. This is a 3200 DIMM, so I believe we can get 3200 DIMMs working here. So what I want to know is what's on the other side to have a look at the cooling. As you can see, someone's already removed this because everyone who gets this wants to see on the other side. Look at that, we got the PC out. How well designed is this thing? Like everything comes out and the whole case is kind of screwed on the side of this PC, but there's like a PCB on top of a PCB, as you can see.
But we must look a little closer.
There's like another one over here, which I think is the graphics card in there. So I think this side there, this PCB there on the bottom, yeah, as you can see, this connection over here, and this will be probably the X16 slot for the graphics card or graphics card slot. Then you've got another PCB on the other side, and this is the graphics card cooling, as you can see. All this, it's like a little laptop graphics card that goes in there. Yeah, you can see here's the ports of the graphics cards on this side, and then you have the graphics card cooling in there. As you can see, there's 2 heat pipes actually running to there. But the cool thing is that they haven't actually put everything on the same kind of PCB. They've got a separate PCB for the GPU and separate one for, I think there's a front panel ports there as well, a little PCB. And interestingly, that's like an M.2 expansion slot in there, as you can see. And then you've got your CPU cooling in here, which we have another 2 heat pipes in there for the CPU that comes out from this side. So how compact is this? How cool is this? I am liking it a lot. Now the next task is to put it back together and test it. Something over here that says a nano SIM, and I'm not sure what's going on over here, but I guess these ports or like these kind of connectors haven't been installed, but you could install something like a actual SIM card reader as well, or SIM card, so you could have like a 4G, 5G, you know, mobile network as well connected to this, which is interesting. Okay, here we are. We have logged in and we've got the Zotac working here. Now this is the task manager here, just to show you. This is the 11th gen i7-11800H processor. And if we're talking about the processor just a little bit, so this is the actual previous generation processor, and I can't wait when this comes actually out for the 12th gen as well, because that would be absolutely even more amazing. But to see, this is a 45 watt TDP processor. It's 8 cores. It's actually 10 nanometer process, even though the 11th gen on the desktop size of CPUs like 11900K, 11700K, they are on the 14 nanometer process, but this is actually 10 nanometers. So this is like the new process, but the older architecture, if that makes sense. It does support up to 3200 mega transfers per second. So you can just get anything like from Crucial, Kingston, something like that, 3200 mega transfers per second, go for it. Interestingly, it says here it supports 128 gigabytes if you have 4 channels, but this one there has 2 channels, so you can get up to 64 gigabytes there. Now, in terms of the iGPU that's inside this processor, it says Intel UHD for 11th gen processors, which should be the UHD 750 processor. But actually, if you look at it very, very closely, it's got multi-format codec engines here, which is 2. But now on this side here, you can see that this is 11900K graphics, which is UHD 750. If you look at the execution units are the same and so on. But if you look at the Intel QuickSync video, it's yes, but it doesn't have 2 media engines. So basically this iGPU is really like a 12th gen GPU there with the 2 media engines inside there, which is very, very good for creators if you want like good hardware acceleration playback in Premiere Pro, DaVinci Resolve, especially H.265 codecs. So what I want to know is how fast is the actual SSD there, and is it Gen 4 or Gen 3 slot? Interestingly, the actual NVMe that they installed over there, or that it comes with a sample unit, this reads about 2.4 gigabytes per second, something like that, which is actually very, very slow, and it's Gen 3 speeds. But the 2 slots in there, if you remember when we opened it up, one of them is Gen 4 X4 slot, and one of them is Gen 3 X4 slot. So you can get one Gen 4 drive and one Gen 3 drive. As you can see, here we have the graphics card, Intel GPU, so this is the UHD graphics. Here we have the NVIDIA RTX 3080 laptop GPU. If you're familiar with the desktop variations of these GPUs, then you can get the 10 gigabyte version and then the 12 gigabyte version. But interestingly, check this out. This laptop 3080 has 16 gigabytes of dedicated memory, which is just absolutely amazing. Firstly, let's have a look at the CPU performance, what we're gonna getting, how good is the cooling, and so on. So we're gonna press start over here, and then let's get hardware monitor up and see what happens. We have 43 watts pulled from the socket straight away, 73C. Actually, look at that. We're pushing 70 watts at the moment, and honestly, it's not loud at all. I've had the some mini PCs are much, much louder than this. I wonder how long will it keep that 70 watt boost. It should drop down to a little bit lower. Okay, now we're pulling down the wattage, about 53 now, 54. What impresses me about this PC and about this cooling is that, look at that, we're only at 80C. Usually with these smaller PCs, we're seeing instantly like 90s and so on. And this is one of the reasons why you might want like a PC, small PC like this, instead of a laptop, just because inside of a laptop, the cooling is so much more limited and you can't push it that far. But when you have it outside, even though it being laptop or mobile CPU, it is much better because it can run much cooler, which means boosting higher, clock speeds, keeping the power draw for longer and so on. 150 watts through the GPU. And if we are looking, what's the temperatures? They're still climbing. Let's see how well does the GPU temperature handle this. The interesting thing is, because this is 150 watts, it's roughly about half as what you would get on the desktop. Like desktop RTX 3080s, depending which model you're going to get, is between 320 to 370, something like that. So this one here is about half of that, and we can see that it's still climbing a little bit depending on your ambient temperature as well. It's 85°C now. What I want to know in a moment is how much does it differ from dedicated RTX 3080. Now the interesting thing here is that I don't know why is there 16 gigabytes of VRAM instead of 12 or 10 gigabytes like you would get on desktop version. Now for some of the creators this is awesome, like if you're a 3D or you're doing some kind of DaVinci Resolve or some other things where you can utilize all of this VRAM there, then it's very good to have this laptop GPU and maybe very something compact. And even now when this is 100% utilized, it's still fairly quiet. Like some of the laptops go much louder because the fans are bigger. They're not that loud at all. It doesn't make a lot of noise at all. Okay, looks like we're now hovering and staying somewhere around 86 degrees in the hot spot and about 81 degrees, just under 81 degrees in terms of GPU temperature. Now, if I keep this going for any longer, it's just going to heat the room up and, the temperatures are going to rise just because the ambient temperature is going to rise as well. But as you can see, that's how this GPU is going to run like maximum, roughly around 81 or so. It's hottish, but it's still able to do that. So now, let's have a look at the RTX 3080 scores then. First of all, let's have a look. It only pulled 88 watts. So people who say that, oh, M1 GPUs don't fully spin up during this Geekbench test, then look at that. On the Windows, it's exactly the same thing. 88 watts instead of 150, as we saw pulled previously. So I'm going to do one more test just in case this is not correct there. But about 147,000 points is actually just a bit faster than RTX 3070. So really, even though being RTX 3080 in there, this is RTX 3070 desktop variation, or as good as a desktop RTX 3070. It consumes less wattage or less power than the RTX 3070 like desktop version. As you can see, a little bit higher score now. It also has more VRAM, double the VRAM as desktop RTX 3070. So more energy efficient, more power. I mean, look at that. The efficiency or power per watt is really good. Bear in mind, if you look at M1 Ultra, for this, test for a metal score on Geekbench 5, then the M1 Ultra gets about 102,000. So this is about 50% faster and consumes about the same amount of power during that test, or, a little bit more. But performance per watt, very good for this in here. So there is an OC menu over there. We can see active cores or turbo mode enabled, of course. That's the whole OC menu. I mean, not much, basically on or off. Interestingly, you have a manual fan mode here where you can adjust the fan speeds manually, which is pretty good. I mean, BIOS is very basic. So then, we're back and I had to reinstall the Windows on this, wipe it all and then get it all clean just because there was too much stuff going on and I didn't think it was fair, benchmark comparisons. Basically, look at this now. Cinebench R23 score 10,000. It's exactly the same CPU. I know the GPU is different in here on this one, but the CPU is the same. So now let's have a look at like the thermals of this actual test here then. Let's have a look at if this CPU is any different. Interestingly, it says core thermal throttling straight away. And look at that, that's 80C instantly, 81C. That's a lot more than the 3080 with 11808. But as you can see, the core clock speeds are actually much higher. Not sure if you remember the previous one, that was like about 2.5 or something like that. But this one here keeps it at about 3.2, went under down, 3.1, slowly clocking itself down, as you can see. Trying to keep it there, but we're still going 82C. It's slightly hot for this. So as you can see, we got a little bit of a lower score because it's already been hot and like thermally throttling. In terms of CPU performance, it's exactly the same because it's the same CPU. Just to show you that it is exactly the same RTX 3070 laptop GPU. And now we have 8 gigabytes of dedicated memory. Everything else is the same. So I want to do the CUDA benchmark here, and then let's have a look what happens on the hardware monitor. Okay, so interestingly here, if you look at the CUDA score here now, previously the 3080 got about 148,000 or something like that. So we're not that much lower. So in terms of the Founders Edition RTX 3070, that scores 147,000 points in the CUDA score. So when we looked at the 3080, that was quite a bit different compared to the desktop size and then laptop size. The laptop 3080 is pretty much like desktop size 3070, but now the 3070 laptop size is slightly lower than the desktop size RTX 3070. As you can see, the GPU is pushing 124 watts, and to me, looking at what's going on there, it looks like it's the same cooling, so I expect the cooling to be better on the RTX 3070, and it's probably going to run a little bit quieter and cooler than the RTX 3080 that was pulling 150 watts. So when we're looking at the desktop size RTX 3070, that pulls 220 watts. But here the laptop one pulls about 100 watts, 95 watts less. So it's not like half of the, TGP or half the wattage as we saw on the 3080. The 3080 was pulling less than half of the desktop size. So then looks like we're kind of equalizing here in terms of the temperature. The hotspot is 83.2 degrees, something like that. And the GPU temperature is 76. So the RTX 3080 was running in the 80s, and then the hotspot was a little bit higher as well. Okay, so this is the 11400H now, and we have an RTX 3060 GPU. So if you're looking at this CPU now here, we've lost 2 cores and 4 threads. As you can see, the RAM and everything is the same. And in terms of the GPU, interestingly now, the multi-format codec engine on the 11400H, there's only one. So you get one media engine instead of 2 on the 11800H. Other than that, everything else seems to be the same. Okay, let's start the test and see what's going on here then. Pushing 51 watts. Interestingly, this is straight away 86 degrees or 87 degrees. Thermal throttling instantly. Well, let's have a look at what the score is going to be like. Okay, 85,000 points in terms of multi-core. And the interesting thing is we pushed a maximum of 51 watts through. Interestingly, because it's the same cooler, why wouldn't this 11400H push more wattage through? I don't know. They could have configured this to push the same wattage through because it's the same cooler. I understand that in a laptop where you would put this in, it might have a smaller, cooler or like a worse of a cooler or cooling properties. But in here, they're all exactly the same, but still not far behind from like the 2 cores that have more, about 10%, less. So then, now the RTX 3060 laptop got 109,000 score, where oh, now that's very interesting. If I'm looking at the Zotac RTX 3060 amp white that was dedicated big graphics card, for the desktop, that graphics card actually got 106,000 points. Look at this. This is 110,000 points. This laptop RTX 3060 is actually more powerful or as powerful as the desktop size RTX 3060. The only difference with this laptop RTX 3060 is that the desktop one has 12 gigabytes of VRAM, whereas this dedicated on this laptop one is only 6 gigabytes. So that's very, very interesting. In terms of just GPU calculating performance, it is as good as the dedicated desktop size RTX 3060, which is very, very interesting. Now let's have a look at how much we're pulling through. 114 watts. And then the desktop variation of this GPU would be pulling 170 watts. So we're only about 55 watts less than the desktop equivalent. While the GPU's test is going, I want to plug in the SD card reader and test the SD card reader as well on these to see if this is UHS 2 speeds. Okay, unfortunately this is UHS 1 speeds. As you can see, we're pulling only 80 megabytes per second. If it was UHS 2, we'd be getting close to 300 megabytes because this card is V90 rated and it can read up to 300 megabytes per second. But nope, it's UHS 1 speeds, unfortunately. Okay, we have equalized now, and then the hotspot is 80.8, so not much different from the RTX 3070. GPU temperature 77 C, so slightly less. So then, conclusion about these little mini PCs then. Sometimes you can't rig the big PC with you. Sometimes you can't put a big PC behind the monitor, or honestly, for creators, there's always like very interesting ways how you can use these smaller PCs. You put it somewhere and it's very, very powerful as well. I mean, powerful not just from CPU and GPU performance, and you have a few configurations, depends like how much you want. You can upgradable RAM, that's awesome. Everything that's upgradable yourself is amazing. You know, SSD upgradable yourself, amazing. 2 NVMe M.2 slots, 1 Gen 4, 1 Gen 3 slots, absolutely amazing. Everything is serviceable, like user serviceable. Something goes, you can just service it. Upgrade your Wi-Fi, no problem. So in the terms of that, I'm very, very happy with that. The 2.5 gigabit LAN as well is amazing to connect with your like local NAS system or network system, and actually quite editable off the NAS as well. Now, the only two downsides that I would have is the actual SSD card slot. I wish this was UHS 2 speeds, but you know what, better this than nothing. And I'm so glad this is full size SD card slot, not like a micro SD card slot. Thunderbolt port in the front as well, so you have quite a lot of expandability if you need it. And not so much of the downsides, but much what I'm looking forward to is to see this as 12th gen. I'm super excited for this to just have on a desk or something like that. And then because it has an RTX 3080 in it, you can do lots of screen recording, you can do streaming, you can do all sorts on this. It's so powerful to have that in there. And the RTX 3060 version of this is not actually much different than the desktop size, which is just amazing. Only obviously the downside is the VRAM there. So if you are a 3D creator, maybe go with a 3080 to get 16 gigabytes of VRAM. So let me know what you guys think, and if you want to pick them out, check them out in the description below. Thanks guys for watching, and see you soon. Bye bye.